I'm Shweta Ketty, Assistant Professor ECE Department. Today we are doing experiment 2 of ADST lab. The second part, that means we are designing the oscillator circuit using crystal oscillator. Earlier in part A, we designed the oscillator circuit using Colpitt's oscillator. That means using this tank circuit. Tank circuit means it is a LC connection. We are using one inductor and two capacitor. Now in place of inductor, we are using crystal. That's why we call it as a crystal oscillator. Okay, and we also designed the capacitor value as, here we were using 1 nanofarad and 2 nanofarad. In crystal oscillator circuit, we are designed to take capacitor value as 22 picofarad and 22 picofarad, and here the crystal we are taken it as 2 megahertz crystal. Okay, now we'll do the rig up of this one. As I told earlier, it is until this portion it is same as experiment 1, and this portion is also like a tank circuit as we had done in Colpitt's oscillator. Only in place of inductor we are placing a crystal. Okay, and also we are replace the capacitors also. Okay, now we'll see the connection. So what we have to do, from till this capacitor we have already done the circuit connection. Now we'll start only this portion. As you can see, one end of the crystal is given to the 0.47 microfarad capacitor. Okay, and also one end of 22 picofarad is also given to this point. Now this is crystal oscillator. Okay, now I'll take this is a crystal, 22 megahertz crystal. I need to connect one end of this into the 0.47 microfarad capacitor, and the other end I'll give it here. Okay, from this end I need to give it back to 0.47 microfarad. I'll do it that later. Okay, now we'll see this capacitor value. The one end of this capacitor is given to this is 22 picofarad capacitor. The one end of this is given here, and the other end is given to ground, so I'll use somewhere in between. Okay, and also to that in series we need to connect one more 22 picofarad, as you can see here. So I'll use that one more 22 picofarad, and that has gone to crystal, other end of the crystal, so I'm using here. Okay, now the capacitors, in between the capacitor we are given to ground, so we also need to do the ground connection. This is the middle point of the two capacitors, that I am connecting it to ground. Okay, and now from this point we need to give it back to the capacitor which is connected to base. So from this point I need to give it to 0.47 microfarad of capacitor which is connected to base. This is that capacitor, and this is the point. Okay, I connected. This is how the connection is made. Now in order to see the output, I need to connect to CRO. So as I told earlier, we are using only a single channel because we are not giving any input, we are seeing only the output. So from the CRO, the positive end has to go here. Okay, so it is this point, and negative end is given to ground. Okay, that's the end of connection. The only input supply we are giving here in this is the DC supply, and that has to set to 12 volts, which we have done already. Okay, now we'll see what is the output we are getting at the CRO. So as you can see here, you can able to see the output. Okay, now again we need to find out what is the frequency of oscillation. In order to find out the frequency of oscillation, I need to find out first the time taken to complete one cycle. Here if you can see, this is, if I take this as a starting point, in order to complete one cycle, this is the positive cycle and this is the negative cycle. So this entire box is making just the right position. Okay, one positive cycle and one negative cycle is almost covering only a single box. Okay, now this time taking is only one box. I also need to multiply this with time per division. What is the time per division? You need to check where this black color notch is pointing. Here it is pointing to 0.5, and also I need to see the unit is microsecond, so it is 0.5 microsecond. Here the box is 1 and the here it is time is 0.5 microsecond, so that means it is 1 into 0.5 microsecond. So what is the time taken to complete one cycle? It is 1 into 0.5 microsecond, that is 0.5 microsecond. But what is the frequency I want? Frequency is nothing but 1 by t, that is nothing but 1 by 0.5 into 10 to the power of minus 6, that will give you 2 mega